Thank you for joining me on this episode of Watch Mr. Coon Solve It. So what we're continuing to do is discuss exponential functions. I already did a introductory video where I talked about populations. Here what I'm going to do is go back through a little bit more detail about what an exponential function really is and the different components of it. So to start with, we're going to look at the values for a, b, and x and whatnot. So I gave you the equation right here. And now I want to talk briefly about what each of these is. First and foremost, a cannot be 0 ever. A is equal to 0, it means your start value is 0, which makes no sense whatsoever. And you can't grow any. So if you're starting with nothing, you can't grow into anything. So if you have one person, well, that doesn't make sense for the human population. Let's say you have one microbe. One microbe splits into two and you have growth. But if you have 0 microbes, well, that doesn't make any growth. You have nothing to start with. You can't go anywhere. You can't invest $0 and get anything out of it. You have to start with something. B is greater than 0, and B is not equal to 1. We're going to talk a little bit in depth about why B has to be non-1 and non-0, and greater than 0 for that matter. Mainly, if B is negative, you get all sorts of funky things happening with the graph. It pops up and down and all sorts of things. It's a non-continuous equation at that point, and it's not a function at all. There are things we can do with it, but it doesn't really make a whole lot of sense for our purposes. B cannot be equal to 1 because if B does equal 1, let's say you start with 1 microbe and the value of B is 1. Well, 1 raised to 1 any power is 1. 1 times 1 is still 1, so the microbe population is not growing any. So down here, 3, that's your A value, right? That's also what you start with, okay? Your B value here is 2, right? Well, that's 1 plus 1, which means that that's 1 plus your rate. Your rate here is 1. And you're saying, well, wait a minute. You said the rate couldn't be 1. No, I said the B value couldn't be 1. The rate here isn't 2. The B is 2. The rate is 1. And you're trying to wrap your head around that, I'm sure. So you can pause and think about that for a second. But what we're saying here is the rate could be equal to 1. The rate is a percentage. It's telling you what percentage of growth you have. So here we're saying we have 100% growth. Okay. If B were equal to 1, right? If this B right here was equal to 1, what it means is you have 1 plus 0. So that means R is equal to 0. So you have 0% growth. Okay. Is that making hopefully that's making a little bit more sense now. And if when we talk about B being negative, well, B being a negative value doesn't really make a whole lot of sense either. And we'll do some more examples maybe in some other videos of why that works. Quadratic functions, basic quadratic function, right? Basic exponential function. What are the differences? Well, first and foremost, you can see it very clearly. Quadratics are symmetrical, exponentials are not. Okay, if I were to put the axis somewhere there and say there, or even say there, both have y-intercepts, but only the quadratic is going to have a 0. The exponential goes back to the value of a being non-zero. That doesn't really make sense for the exponential to ever have a 0. And play around with it and think about what an exponential is defining for us. It makes sense that it can never be 0. Additionally, quadratics have minimums, right, or maximums. An exponential doesn't. Okay, and there's lots of things we can discuss. And I encourage you to pause it and just make a list for yourself of all the things that are true about both of these, and make it a really exhaustive list. And maybe put those things in the comments below. You just list these are all the things I found that were the same. These are all the things I found that were different. Leave those comments for each other, and you'd be surprised how much it could help you in understanding what these graphs mean and look like. So going back to this idea of growth and decay of exponentials, though. What does it mean for it to be growing exponentially? Well, it means the value of B is greater than 1. So that means that, remember that definition from the previous page, I said that B was 1 plus rate, right? So this is 1 plus R, right? Which means that R is greater than 0, right? Well, down here, decay, it means that B is between 0 and 1. So that means, again, we're talking about 1 plus R. Well, what has to be the value of R now if we're talking about it being between 0 and 1? Well, that means it has to be between -1, right? R has to be greater than -1 because we can't have a B value smaller than 1. but it also has to be less than 0. Right? So we're talking about rates that are strictly between 0 and -1, or negative decimals, are what are going to give us decays. Okay? R value greater than 0 will give us a growth. R values between -1 and 0 will give us decays. And you may be asking, well, why can't we have something less than -1? Well, it goes back to the equation itself. If we say that R is -2, that means that the B value is 1 plus -2, which gives us -1. And then you're saying -1 raised to some power. Well, that's fine when you take to the first power, which is this -1. But what happens when you square it? Well, all of a sudden that -1 becomes +1. What about when you cube it? Well, then it's back to -1. So you end up with a graph that looks like this. And it's just growing in both directions, up and down. And it, for our purposes of talking about money growth or population growth or even decays or anything else, it doesn't make a whole lot of sense for us. Really doesn't make any sense whatsoever. So that's why we say R cannot be less than -1. Okay? It just makes things a little bit simpler. So that red line down there is our decay equation. The green line is our growth equation. And they both have y-intercepts, both have the exact same shape, and they're essentially reflected across the y-axis when we go from one to the other. Okay, so that's exponential growth and exponential decay. When you're wanting to solve problems, you're just looking for making sure that you can identify, going back to this value of b here, or even if you want to go use one of the other forms of the equation, that rate value needs to be negative. It needs to be between -1 and 0 for decay, and R has to be greater than 0 for it to be a growth. All right, so thank you for joining me here today, and please leave any questions in the comments below, or email me if you have access to that email address, and I'll get back to you as quickly as I can. Thank you.